Okay, welcome back to the last lesson in Unit 7 on matrices. This begins on page 14 in your notes, and it's really exactly the same thing we were doing in our last class. You're still going to be using matrices to solve systems of equations. What these involve real-world problems. Okay, so let's have a look here at the first one. And it says for a particular electric circuit, the equations used to find the currents in amperes I1 and I2 are, reminds me of a Charlie Brown cartoon. Wah, 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 wah. All that really matters here is that you see what your variables are and you see what you have to do to solve this system. And of course, yes, you should use the proper units when you're answering this. Notice the first equation. Here's your I1. And that's one of your variables. And the other variable is I2. But this equation, they're kind of all mixed up. And this one you'll notice starts with I2 right there. And here you have I1 plus I2 in brackets. What you should do with these equations first is multiply out, use your distributive property. Second equation, the same thing. All right, use your distributive property and multiply out there. Group together your like terms. And if you do so, I've got the answer right here. I'll just write down what the answer is rather than spend a lot of time on showing the algebra. You're going to get 8 point, no, I hope I've got room here to write it down. 8.75, actually I should write it down here. 8.75 I1, and it's plus 6.45 I2 equals 15.0. That's your first equation. All right. Your second equation is going to be 6.45. And now notice the odd ones must line up one out of the other. Plus the second variable there, the second term becomes 7.70 I2. Now make sure that algebraically you can determine these. You can get these on your own. It's not difficult. And it's equal to 12.5. So there's what the equations actually become when you write them in the proper order. And now, make sure you write as well the matrix equation that you're writing. That's, I do want to see that. So you're going to have 8.75, 6.45, and 6.45 here, and 7.70 down below. That's your coefficient matrix. You're going to multiply that by now your variables now are I1 and I2. Remember that when your calculator gives you back the answer, I1 is first. Right, that's the top number. That's like your x being first. And now you have 15.0 and 12.5. So there's the matrix equation that you're actually going to use to solve that system up there. So that part I would like to see on a test or on a quiz. You should show that, what matrix equation you're actually using. Now it's not necessary to write down what the inverse of that first matrix is. Your calculator is going to do that work for you. And remember now you can call this matrix here A and multiplied by, and this matrix here, well, they were calling it capital X, and you can still call it capital X. And this is the coefficient. Call it whatever you like. If you want to call it C, fine. On the calculator, I usually use B, but you call it whatever you like. So let's go ahead now. I'm going to get my calculator once again. Here we go. There's my calculator. All right. I'm not sure you can actually see all of that or not. I wonder, can I make it a little smaller? Oh, look at that. Yes, I can. All right. I hope you can still see it, by the way. So now, what I'll do is I'll turn my calculator on. Turn the calculator on. If you have to clear the memory, by the way, of your calculator, because you may have other matrices in there from a previous calculation, it's second and the plus sign. You'll notice above the plus sign MEM. And you want to reset, so it's 7, number 1 for all RAM, and number 2, the calculator is just making sure you really want to do this. Do you really want to do this? Yes, I do. So hit number 2. So there you go, the RAM is now cleared. Any old matrices that you had in there previously are now gone. So here we go, second matrix. I go over to edit, and this is matrix A. So I'll just type enter. It's a 2 by 2, so 2 enter, 2 enter. And now the numbers this time are decimals, so 8.75. and the second, or the first row, second column is 6.45, that element. Type that in, and then there's another 6.45 down below in the second row. And finally, we have 7.70. Now, you don't need to type in the 0. You can if you want. Your calculator doesn't know the difference. And enter. And now you can quit that. And now let's type in the second matrix. So it's B. I'll go over to edit once again. And now it's number 2. Or you can use your arrow keys to come down until number 2 is highlighted and press enter. 2 by 1. And so that was 15.0 was the first number. Again, you can just type in 15. And 12.5 for the second number. And basically, that's all the work you have to do. Now, clear my memory, or not clear the memory, clear my screen, go back into my matrix. I'm using the names this time. I'm not editing them. So I just hit enter, matrix A, hit my inverse button, I hit my times up button, and I go second matrix once again. And now it's number 2 because this, what I call the second matrix, was 2, my coefficient, or sorry, my constant matrix. Call it what you like, doesn't matter. Oops, look at that, I hit the wrong button. I have to go back there and delete that. That's supposed to be inverse. There we go, that's better. Now just hit enter, and you get some pretty nasty looking decimals there. It might be possible to convert them into fractions, but it's not really necessary because, I mean, this is the answer to a real world problem. So if you wanted to, when you write down your 2 solutions now, you would have something like I1 is equal to, and the number was 1.35 approximately, and use the unit as well. Now notice that they tell us here that it's in amperes. All right, so there's the current. I suppose it's current. I know practically nothing about electricity. And the second variable, I2, was approximately 0.49 amperes. And that is basically all we do. The word problems, basically, if you can solve a system of equations using your calculator and matrices, these word problems, well, they're just basically the same thing. You're just solving an equation, solving a system of equations. So now if you look down here in question number 2, I can see 3 equations, and yes, I can see 3 variables, IA, IB, and IC, subscripts. Okay? In applying Kirchhoff's law to a circuit, the following equations are found. Determine the indicated currents. Okay? So all you would have to do there is, well, set this up correctly. Now I can see that the I's and the B's and the C's, technically that equation is okay, or that system is okay, it's in the right form already, but you'll notice some of the variables are missing here. So to write this as a matrix equation, all right, let's see what that would look like. The coefficients in front of I subscript A, I subscript B, and I subscript C is 1, 1, 1. The second equation, IA, there's a 2, and IB is -5. Now, what's missing is the I subscript C. So what we assume is this, think of it as being there, but having a coefficient of 0. There's a 0 in front of it, so it disappears. And in the third equation, the I subscript A is missing, so that becomes a 0. I subscript B has a 5 in front, and I subscript C has a -1 in front. There you go. There's your coefficient matrix. You're going to multiply that by the variable matrix. Okay, we'll put down IA, IB, and IC. Now you can't really see all that well. This pen of it is not the greatest. And it's equal to, yeah, I mean, that wasn't too bad at all. 0, 6, -3. So again, what you're going to do now is you want to call this one A, that's fine. You don't even really need to name this one because you don't actually type it into your calculator. And I'll call this one B. So what you're actually going to solve, the equation is A inverse multiplied by B again. In that order. The order is important. It has to be in that order. So anyway, if you type it into your calculator, now my calculator I think gave it back as fractions. You can give us fractions if you want, but typically for a real world problem, you wouldn't give the answer as a fraction. Okay? I'll just write down now what the answers are for this one. All of this is shown anyway in the full workings. So IA is equal to, now this is current. Current, I think that's amperes as well. Yeah, okay. So 21 over 7 over 17. Now that's if you want to give it as a fraction, but again, that's not necessary. I'd probably just use a decimal there, everyone. And that's amps. IB turns out to be negative 12 over 17 amps. And I subscript C is equal to, and it's negative 9 over 17 amps once again. But like I say, solving word problems is really no different. You're just solving a system of equations is what you are doing. So practice those, please. Make sure you practice that. Here, if you look at question number 3, let me see. 2 electrical resistors, R1 and R2 are tested with currents and voltages such that the following equations are found. That could have been Latin, and I wouldn't know the difference. 2R1 plus 3R2 equals 26. 3R1 plus 2R2 equals 24. Look at that. They're set up for you beautifully. They're set up for you beautifully already. Nothing to change. Just type those into your calculator. 2 by 2 for the coefficient matrix. 2 by 1 for the variable and constant matrices. And just practice that one. And on the next page, number 4, let me see. Anything there that might be tricky? Nope. Looks pretty good to me. Everything is lined up okay. You just have to use your calculator with a 2 by 2 system. And number 5, number 5. Now, I don't think I'd give you one like number 5 on a test. But I will explain how to do it. Now, in order to do this one, now back when I was doing matrices, there is something you're allowed to do with all these rows and columns and things like that and switching them around, but I'm not going there. The best thing to do if you're even going to venture to try this one is to, first of all, multiply that thing out manually, because you can't type it in your calculator, you see, right? Remember now how they get multiplied. Rows in the first matrix, columns in the second matrix, and they're equal to these things over here. So your first equation would be x multiplied by 1, well, that's x, and then 2 multiplied by y, okay, that's plus 2y, and then plus 2 multiplied by z, well, that's 2z, and it's actually equal to this first number over here, which is negative 4. So there you go. You'd have to take that equation out and sort of take that around. The second equation would become, okay, 18. Now you're going across the row, remember, and down this column. So 18 times 1, well, let me see, I think that's 18. And then 9, right there, multiplied by the y, plus 9y. And then 10 multiplied by z, or positive 10z. And that's equal to negative 4x. Look at that. Wow. All by itself. And finally, you then multiply the negative x by 1, that's negative x, and then 3 times y, that's plus 3y, and keep going across, 7 times z, plus 7z, and that would equal the final number there, which is negative 7. Now, of course, that's still not in a proper form. That's not in a nice form for typing it into your calculator or anything. So you'd have to rearrange everything here now. Make sure everything is lined up, x's, y's, z's. Your equal signs need to be lined up as well, and your constants had to be lined up. But like I say, I'm highly doubtful I'd give this one to you on a test or a quiz, but you can have a look at it and try. So anyway, everybody, that's basically it. After that, page 16, 17, and 18, actually they show the Casio there. That appendix shows you how you can do a lot of stuff on your Casio calculator with the matrices. I wish I had an emulator on this computer, my apartment computer, and I'd bring that up and I'd show you how that's done. I do have one on my office computer, but for some reason I can't get it here. All right, so that's it for the last lesson, and this is the end of this video. Please try those, and again, if you have any questions on anything, don't hesitate to send me an email, all right? And keep checking the solutions on D2L. Make sure you're getting these correct. So that's it for this video. Thank you so much. It was a great pleasure putting these videos up, and I will see you all again later. Bye-bye.